Dear students, in my last video, as we all know that we discussed 20 questions of a KCET 2020 physics question paper. Now, in this video, let me continue my discussion with the 21st question. The question is, the color code for a carbon resistor of resistance 0.28 kilo ohm plus 10% is. Here we need to find out color code for the given value of resistance. Before going to find out the color code, you must convert the given value into standard form. What is the standard form? The standard form is 2 digits times the decimal multiplier plus or minus the tolerance. That should be in percentage. Now this is the standard form. Now let me write this in this form. Now the given value is 0.28 kilo is nothing but 10 to the power of 3 ohm plus 10%. Now we can write here, this can be written 28 into 10 to the power of 1 ohm plus 10%. Now this is in the standard form. You can see that 2 digits, decimal multiplier and the tolerance. Now we can have a color for the values, that is for 2 we have red and for 8 we have gray color and for 1 we have brown. This you know that B.B. Roy of Great Britain had a very good wife wearing gold silver necklace. Here black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver. If there is no color, then we can use 20% of tolerance. So now here, according to this, we can have red, gray, brown, and here 10%, that is silver. So therefore, here the option A would be the correct answer. Okay. Let me move to the next question. Each resistance in the given cubical network has resistance of 1 ohm and equivalent resistance between A and B is. Here we need to find out the equivalent resistance between the body diagonal of the cube. This A and B are the end points of the body diagonal. Okay, if I join these 2 points, we will get the body diagonal. These 2 points are end points of the body diagonal. To find out the effective resistance, let me connect these 2 points to the external source of EMF E. Okay, this E. Let me give the names for this, that is C, D, E, and here let me write here X and Y. Now you can see that consider a current of 3I flowing through this circuit. Now whenever the 3I comes to this junction, that I at A, this 3I is divided into I and I. That means it divides equally through all these 3 resistors. Next, this I current moves to the junction C and here it divides equally, that is I by 2 and I by 2. In the same way, from A to E, the current I will move and then here it divides into I by 2 and I by 2 at the junction E. Now you can see that at the point D, that means to the point D, the current I by 2 is coming as well as I by 2 from C and I by 2 from E is coming to the junction D. So therefore, the total I current will flow towards D. In the same way, here I amount of current and from this I and from this I. Totally the 3I will reach to the point P, because how much current is flowing through this, flowing from A, the same amount of current will start to come, and then it will end at negative end of the source. Now, on applying the Kirchhoff's loop rule to the loop AC, to the loop AC dBxy, what we will get? XYA. Now you say that our direction of concentration and direction of the current is same, so therefore we can write the IR, because we know that the resistance, if it is R, then IR, and here plus I by 2 R plus, here we can write IR, this is IR. So this is equals to the source of EMF, that is E. So this IR plus I by 2R plus IR will become, so 2, 5 IR divided by 2. So this E can be written. So suppose if I convert this whole circuit into an equivalent circuit, or equivalent resistance, that is R equivalent, and which is connected to the external source of EMF E, and how much current we considered? 3I. Now we could write that E equals to how much? E equals to IR, that is 3I into R equivalent. So therefore in place of E I am writing 3IR equivalent. So therefore I and I get cancels, and R equivalent is equals to 2 will come to the denominator, so 3 will come to the denominator, 3 2 ja 6, that is 5 by 6 R. So here the value of each resistance is 1 ohm, so therefore the effective resistance between the ends of the body diagonal is 5 by 6. So option A would be the correct answer. This is the lengthy process of finding the answer. We have a shortcut to find out the answer for such type of questions. Let's have a shortcut now. Now suppose if you want to find out the effective resistance between the ends of each sides or edges of the cube, that means each sides or edges, that ends of the each sides, let me say this is the point A and B. Suppose if you want to find out between these 2 points, what we need to do? If you want to find out between the ends of the each face diagonal, so let me take, this is the face, that is AB CD is one face. The face diagonal is nothing but AC is the face diagonal, or BD is the face diagonal. Between the ends of each face diagonal, that means between the points A and C, or between the points B and D, if they ask how to find out. Okay, suppose if they ask you to find out between the ends of the each body diagonal, here the body diagonals, that let me give the names for this: A, B, C, D, E, F, G, H. Here the body diagonals are AE, this is A and this is E. AE are the ends of the body diagonal, and B and E, these two also ends of the body diagonal. In the same way, this one, that is this G and C, these two are also ends of the body diagonal, or between the points, that is H and D, D and H, these two also ends of the body diagonal. Suppose if they ask you to find out the effective resistance between the ends of the body diagonal, how to find out? Just keep in your mind that you can write here, that is 1, 2, 3 by 4, 5 by 6, 7 R. This is the resistance. This is what you have to practice. You need to keep in your mind this one. So between the ends of the each sides or edges of the cube is how much? 7 by 12. And between the ends of the each face diagonal is 3 by 4 R. Between the ends of the body diagonal, that is 5 by 6. In this question, what so far we discussed, we found between the ends of the body diagonal, that is AB. So therefore answer would be 5 by 6. So in this way we can find out the effective resistances of between the ends of the east sides face diagonal or body diagonal very easily. Hope this will be very helpful for you, and then by using this trick we can mark the option in a fraction of time. Okay, let me move to the next question. IV characteristics of a copper wire of length L and area of cross section A is shown in the figure. The slope of the curve becomes, see here, the slope of the curve becomes, see we know that when we consider the V and I here, we know that the slope is nothing but the change along y axis to the change along x axis. This is what the slope is, nothing but change along y axis. What parameter we have taken along y axis? Current we have taken, so therefore change in the current divided by the change along the x axis, that is change. So this gives us the reciprocal of the resistance. We know that I divided by V is nothing but reciprocal of the resistance, isn't it? Because V by I is equals to R. V by I is equals to R, but here we have taken I divided by V, so therefore 1 divided by R. So that is the slope of this graph is equals to 1 by R. So we know that the resistance is directly proportional to the length, inversely proportional to area, directly proportional to length, inversely proportional to area of cross section. Now more if the experiment, that means slope is more if the experiment is performed at high temperature. Whenever the temperature increases, at the time the Ohm's law is not applicable, we won't get straight line, so therefore option A is not correct answer. More if a wire of steel of same dimension is used, compared to steel and copper, the copper is the good conductor, so its resistance is less, so therefore there will be more slope for the copper, but here they have given more slope for the steel, so therefore this is not correct. There will be less slope for the steel if you take these two materials. Next, less if the area of the wire is increased. If the area of the wire is increased, we know that if the area increases, resistance decreases. When the resistance decreases, what will happen? The slope increases. But here what is happening? What they have given, that is less they have given, so therefore this is not correct. So more, it is more if the area of the wire is increased, but they have given less, so it is not correct answer. Less if the length of the wire is increased. That means whenever the length increases, resistance increases. As the resistance increases, the slope decreases. So therefore decreases means less. Less if the length of the wire is increased. For that reason, option D would be the correct answer for this question. Okay. Moving to the next question. That is, in the given figure, the magnetic field at O is, here in the figure, the magnetic field, let me name the segment, that is AB, magnetic field due to AB, and let me take this one loop, that is B, C, D and D. The magnetic field due to D segment is 0 because it is passing through O. Now the magnetic field at O produced by BCD loop and AB. Now let me consider the AB segment. This is, so we know that the magnetic field due to infinitely charged wire, let me consider at a distance R. If we want to consider at this particular point magnetic field, we have an expression for the magnetic field at a distance R from the infinitely charged straight conductor, that is given by mu naught I divided by pi r, sorry 2 pi r. This is what we have. But here we are considering only AB, that is, this is, let me consider this is AB. So only we are considering half of the portion of this conductor, so therefore we can remove this. If we consider half of the portion, at the time the magnetic field will become half, that is 1 by 2 times, that is equals to mu naught I divided by 4 pi r. This is the magnetic field produced by the segment AB, and the direction of the magnetic field at this particular point is given by the right hand thumb rule. So when we find the magnetic field direction from the right hand thumb rule, we can get the direction is inward due to this segment AB. Now let me go for the magnetic field due to this circular loop, that is BCT. Whenever we consider the loop, we will get the magnetic field at the center due to this loop is B equals to mu naught I divided by 2R. But here we have only the 3/4 part of this loop. So therefore we will get the magnetic field 3/4 of the magnetic field of the loop. So therefore let me multiply by 3/4. This is equals to mu naught I, that is 3 mu naught I divided by 4 to the 8 R. This is the magnetic field produced by the segment BCD at the point O. And the direction of the current is in the clockwise. So therefore the magnetic field will be acting inward. Okay, so therefore the magnetic field produced by the AB segment is acting inward, as well as the magnetic field produced by the BCD segment is also acting inward. So therefore we have to add these two magnetic field, that is 3 mu naught I divided by 8R plus mu naught I divided by 4 pi R. We need to add them because both are acting in the same direction at the point O. So therefore option here C would be the correct answer. Okay. Now let me go to the next question, that is the magnetic field at the origin due to a current element ideal placed at a point with a vector position R is. See here we need to find out the magnetic field at the origin due to the current element. Let me say our aim is to find out the magnetic field at O, at the origin, and the current element is placed at a point with a vector position, that is, let me consider this is a vector position, let me say this R vector. At this point we are placing a ideal, that is current element we are placing here, that is ideal. Now we need to find out magnetic field at O. So we know that from the Biot-Savart's law, that is dB, that is magnetic field at B. So directly I am writing the vector form of Biot-Savart's law, that is dB vector is equals to mu naught divided by 4 pi I dl cross R vector divided by R cube. And whether you are placing the current element at this point or at the origin, it doesn't matter. The magnetic field, that means the direction of the magnetic field is always decided by the direction of the cross product of the dl vector and R vector, that is the direction of dl cross R, not R cross dl. Okay, so therefore we can have dB equals to mu naught 4 pi I dl vector cross R vector divided by R cube. Okay, suppose if you want to write R cross dl, then the direction of the magnetic field will reverses. So as we know that dl cross R vector is equals to minus of R vector cross dl. So dB is equals to minus mu naught divided by 4 pi I R vector cross dl vector divided by R cube. Like this it will become. That means the direction of the magnetic field reverses if you consider R cross dl. So therefore the direction of the magnetic field is always decided by dl vector cross R vector. That means the direction of the dl cross R gives us the direction of the magnetic field. So therefore option which option, that is not dl cross R divided by R cube. So option A would be the correct answer for this question. So here this r cross dl divided by r cube is also correct, but there must be negative sign. If there is no negative sign, this will not be the correct. If they have given r cross dl, then there must be negative sign because the direction of the magnetic field reverses. Okay, so let me go for the next question. That is, a long cylindrical wire of radius r carries a uniform current I flowing through it. The variation of magnetic field with distance r from the axis of the wire is shown by the different A, B, C. So to solve this problem, let me consider a cylindrical wire of radius r. This is a cylindrical wire of radius r. Now whenever we consider the point P inside the conductor, that is the r at a distance of r which is less than r, that is r is less than r, we have an expression for the magnetic field, that is B equals to mu naught I r divided by 2 pi r square. That is, this implies that B is directly proportional to r when the small r is less than the capital R. That means the distance of point of consideration is less than the radius. Now suppose if the point of consideration is at a distance small r which is greater than the r, at that time we have an expression for the magnetic field, that is mu naught I divided by 2 pi r. This implies that the magnetic field is inversely proportional to r outside it. Now by these two descriptions we can say that inside the conductor, as we go on increasing the radius, that is the distance of point of consideration, and the magnetic field, we know that B is directly proportional to r inside the conductor. So therefore up to r equals to r, the magnetic field will goes on increasing. So therefore it is directly proportional. For that reason we are getting straight line graph. After reaching this surface, if the r is greater than r, that is small r, the point of consideration is greater than the radius of the wire, so B is inversely proportional to r, so therefore the magnetic field goes on decreasing. So therefore option C would be the correct answer for this question. Okay, let me move to the next question. That is, a cyclotron is used to accelerate protons, deuterons and alpha particles, that is helium, while exciting under similar conditions. The minimum kinetic energy is gained by. See, we know that the kinetic energy gained by the positively charged particles in the cyclotron is given by kinetic energy equals to q square b square r square divided by 2m. Here under the similar conditions they are saying, so therefore B and R remains constant, so therefore kinetic energy is directly proportional to q square divided by 2m. So now let me find kinetic energy for the proton. Here charge on the proton is, we can take E square divided by 2m only, mass number is 1, so atomic number is 1, so therefore we can write like this. Now kinetic energy for the deuteron, that is the atomic number is 1, so therefore E square divided by mass number is 2, so therefore 2 m is 2 times, so therefore we could write that is half of the E square divided by 2m, that is kinetic energy of the proton, half of the kinetic energy proton will get. Now for the helium, that is here atomic number is 2, so therefore we will write here 2e square by 2 into 4m, so therefore we will get 4e square divided by 8m. This is nothing but e square divided by 2m. So therefore by looking at these expressions, we can write that the kinetic energy of the proton is equal to the kinetic energy of the helium particle, and compared to deuteron, that is the deuteron's kinetic energy is half of the kinetic energy of the proton. So therefore the kinetic energy of the proton as well as kinetic energy of the helium is greater than kinetic energy of the deuteron. So therefore the kinetic energy of the deuteron is minimum in this case. So therefore option C would be the correct answer. Okay, let's have a look on the next question. That is, a paramagnetic sample shows a net magnetization of 8 ampere per meter when placed in an external magnetic field of 0.6 Tesla at a temperature of 4 Kelvin. When the same sample is placed in the external magnetic field of 0.2 Tesla at a temperature of 16 Kelvin, the magnetization will be. We know that the magnetization is proportional to V by T. So by this equation we can write that the M2 by M1, here we have two cases, so therefore we can write M2 by M1. Here M2 can be written like this, B2 by T2, and M1 can be written like this, that is T1 by B1. On substituting the values now, M2 by M1, so in the M1 we have 8 ampere per meter, and B2 equals to, that is B2 here 0.2 Tesla divided by T2. T2 is 16 Kelvin into T1 equals to 4 Kelvin divided by B1 is 0.6. So here 4 1 ja, 4 4 ja, 4 1 ja, 4 2 ja. So therefore it will become M2 is equals to 0.2 divided by 0.6 is 1 by 3. This 2 will come to this side, this right side, it will become 2. So this is nothing but M2 equals to 2 by 3. So therefore option B would be the correct answer. Suppose if you don't have this value, this we can get by using the Curie's law. According to Curie's law, the susceptibility of paramagnetic substances is inversely proportional to the absolute temperature. That is susceptibility can be written magnetization divided by intensity of the magnetizing field, that is equals to this mu naught C divided by T. These two are the constant. Now this can be written as equal to mu naught C by T. Now this M can be written, that is M, that is magnetization can be written like this, that is mu naught H C divided by T. So mu naught H is nothing but the magnetic field, C, that is Curie's constant, divided by T. So therefore the M is, this C is Curie's constant. For that reason the magnetization can be written like this, magnetization is proportional to B by T. So therefore we can use directly this one, that is B by T. In this way we can get the answer for this question, that is M2 equals to 2 by 3. Okay, now let me go for the next question, that is 29th question. The ratio of a magnetic field at the center of a current carrying circular coil to its magnetic moment is X. If the current and the radius both are doubled, the new ratio will become. Here the magnetic field at the center of the current carrying wire, the magnetic field at the center of the current, suppose if it is at the center of the current carrying wire, the magnetic field is B equals to mu naught Ni divided by 2R. This we know, this is general formula. Now, and we have seen the magnetic moment also. The magnetic field, magnetic moment is given by NIA. This IE can be written as pi r square. Okay, now the ratio between these two is equals to X, they are saying, that is B by M, that is B divided by M. This is equals to X, that is B by M is equals to, here mu naught Ni divided by 2R. If I take the ratio, this Ni and Ni get cancelled, so we'll get only the mu naught divided by 2 pi r cube, that is 2 pi r cube. If I take the ratio between these two, we'll get mu naught divided by 2 pi r cube. Already we know that B by M is nothing but how much here? B by M is, they are given according to this, B by M is X. So therefore X is inversely proportional to r cube. Now you can see that if the current is doubled, then there won't be an effect for this x. Because of what, then this x or ratio does not depend on current. But when the radius is doubled, at that time what will happen? Let us see. That is x dash is equals to mu naught divided by 2 pi. If the radius is doubled, how much it will become? 2 2 ja 4, 4 2 ja 8. It will become 8 times r cube. So therefore this can be written like this, no? That is mu naught divided by 8 should be taken this side, 8 2 pi r cube. So we know that the mu naught divided by 2 pi r cube is equals to x. So therefore x dash can be written like this. The x dash is equals to x divided by 8. So therefore option D would be the correct answer for this. Okay now. Now let me go for the next question. Question number 30. In a permanent magnet at room temperature, option A, magnetic moment of each molecule is 0. The individual molecules have non-zero magnetic moment which are all perfectly aligned. Domains are partially aligned. Domains are perfectly aligned. We know that a permanent magnet at room temperature retains a ferromagnetic property that possesses always a dipole moment, and it is at room temperature now. So therefore, due to the thermal agitation, the domains are always partially aligned but not perfectly aligned. So therefore option C would be the correct answer for this question. Okay, let me move to the next question. That is, a rod of length 2 meter slides with a speed of 5 meter per second on a rectangular conducting frame as shown in the figure. There exists a uniform magnetic field of 0.04 Tesla perpendicular to the plane of the figure. If the resistance of the rod is 3 ohm, the current through the rod is. Here the magnetic field is perpendicular to the plane and this rod is moving as shown in the figure, isn't it? Now, because of the motion of the conductor in the magnetic field, EMF will be produced in the conductor. That is referred as motional EMF. Now, that motional EMF is given by the expression that is BLV. That is a motional EMF is equals to BLV, as we know that. Now, this E is nothing but that is EMF can be written as IR, that is BLV. Now, we can find out the current through the rod, that is BLV divided by R. So by substituting the values, that is B equals to how much? 0.04 Tesla, and length of the rod is 2 meter and velocity of the rod is 5 meter per second, and divided by resistance of the rod is 3 meter. So 3 ohm. So therefore here the 5 to the 10, we will get I equals to, I'm simplifying this one, to 10, that is 0.4 divided by 3. 0.4 divided by 3 is 0.133 ampere. But here we have 1.33 but not 0.133. So therefore we can convert this one like this. That is I equals to 133 milliamps. That is milliamps. So therefore the option B would be the correct answer. Okay. Let's move to the next question. That is, the current in a coil of inductance 0.2 Henry changes from 5 ampere to 2 ampere in 0.5 second. The magnitude of the average induced EMF in the coil. We know that from the Faraday's laws, the magnitude of the induced EMF, that is E equals to L di by dt. That is di by dt. Here we have L is 0.2 and the di, the change in the current is 5 minus 2, that is 3 and dt, that is 0.5. So 0.5 is 1, 0.5 is nothing but 1 by 2. So 1 by 2 is 3, 2 is 6, 6 into 2, 6 into 0.2, that is 1.2. That is the average induced EMF in the coil is 1.2 volt. So option B would be the correct answer for this question. Okay. And let us go to the next question. In the given circuit, the peak voltage across C, L and R are 30 volt, 110 volt and 60 volt respectively. The RMS value of the applied voltage is, here we know that the peak voltage can be written like this. The peak voltage, we can write, we have a formula for the peak voltage, that is a peak voltage equals to, that is a V square R plus VL minus VC whole square. Now on substituting the values, you can refer the diagram. Now here the across the resistance, how much we have voltage, that is 60 square plus VL minus VC. VL is 110 and VC is 30, so therefore it will become 80 square. So therefore V naught is equals to 36, 64, 100. So therefore we can get the V naught is equals to 100 volt. That is V naught equals to 100 volt. Now we need to find out actually the RMS value. We have a relationship between peak value and RMS value. That is the VRMS is equals to peak value of the voltage and root 2. So that VRMS is equals to the V naught, just now we found, that is 100 divided by root 2. So root 2 value is 1.414. So VRMS is equals to 100 divided by 1.414. So this will be equals to 70.7 volt. So therefore option C would be the correct answer for this question. Okay. Let's see the next problem. The power factor of RL circuit is 1 by root 3. That is power factor. We know that is cos psi equals to how much they have given, that is 1 by root 3. If the inductive reactance is 2 ohm, that is XL equals to 2 ohm, the value of resistance is, here we know that cos psi is nothing but R by Z, isn't it? R by Z, that can be written like this, so root 3. Now on cross multiplying we will get Z equals to root 3x, so root 3R. Now we have an expression for the Z, that is R square plus XL square, that is root R square plus XL square is equals to root 3R. Squaring on both the sides will get R square plus XL square is equals to 3R square. So now we have a value of XL, that is 2 ohm. So therefore if I substitute here 2, then 2 2 4, so therefore R square plus 4 is equals to 3R square. So if I bring 2R square this side, it will become 2R square, that is 2R square equals to 4. So therefore if I bring 2 this side, then 4 by 2, 2. So therefore R square is equals to 2. This is nothing but R equals to root 2 ohm. So option B would be the correct answer for this question. Okay. Now we shall move to the next question. Here in the given circuit, the resonant frequency is, the given circuit is tank circuit, so therefore, or else oscillator circuit, which is consisting of inductor and capacitor, which is producing oscillation. So therefore the frequency of the oscillation is given by the expression, that is f equals to 2 pi square root of LC. So on substituting the values, that is what, 1 by 2 and pi value is 22 divided by 7 root, here L is 0.5 millihenry, that is 10 to the power minus 3, and C, that is 20 micro, 10 to the power minus 6. So this is equals to 1 divided by this, 7 will go to the numerator, that is 7 divided by 22 into 2, that is 2 into 22. Here we have 0.5, that is nothing but 1 by 2. 1 by 2 into 20 is 10. So here we can write 10 and 10 to the power minus 9. So how much it is? Root 10 to the power minus 8. So therefore we will get 7 divided by 2 into 22 into 10 to the power minus 4. So therefore if minus 4, 10 to the power minus 4 go to the numerator, then it will become, that is F equals to 70,000 divided by 2 into 22. So that's what 22. So on simplifying this, that is 7,000 divided by 2 1 ja 2 35,000 and 2 11 ja 2 1 ja 2 7 ja 14 2 5 ja. So therefore 11 1 ja, so we will get 1592 hertz. So here the option C is the right answer. Okay, let's have a look on the next question. That is, a light beam of intensity 20 watt per centimeter square, that is intensity 20 watt per centimeter square, is incident normally on a perfectly reflecting surface of sides 25 centimeter into 15 centimeter. The momentum imparted to the surface by the light per second. We know that the energy is equals to mc square according to Einstein's equation. This can be written like this: mc into c, that is mc is nothing but momentum into c. So therefore momentum can be written like this: p equals to E divided by c. See that if there is a plate and if it is a perfect absorber, then we can write the momentum imparted is E divided by c. And if you consider this is the perfect reflector, how much amount of energy it will absorb, the same amount of energy will be liberated. So therefore P plus P it will become. So therefore we can write momentum is equals to 2E divided by C for perfect reflecting surface. For perfect reflecting surface, P equals to what? 2E divided by C. So therefore we can write the momentum imparted to the surface is 2E divided by C. As you know that the intensity is nothing but the energy per unit area of cross section. So therefore E can be written like this now, that is IA. So therefore I am using here, that is 2 times IA, that is IA divided by C. So on substituting the values, that is 2 into the I, how much intensity we have, 20, and area of cross section is 25 into 15 divided by the C, that is speed of light in the vacuum, that is 10 to the power of 8. We have 3 1 ja 3 5 ja. So therefore 25 to ja 50 or 5 to ja 10, 10 into 25 250, 250 into 10. So therefore we can write this is equals to 5000 into 10 to the power of, if it comes to the numerator, it will become 10 to the power of minus 8. This is momentum, that is kg meter per second. Now this could be written like this, that is the momentum. This is nothing but 5 into 10 to the power of minus 5 kg per meter per second. So therefore option, that is option C, is the correct answer. Okay, let me move to the 37th question. An object approaches a convergent lens from a left of the lens with a uniform speed 5 meter per second and stops at the focus. The image moves away from the lens with a uniform speed 5 meter per second, moves away from the lens with an uniform acceleration, moves from the lens with a non-uniform acceleration, moves towards the lens with a non-uniform acceleration. Here an object is approaching the convex lens. So if the object is moving towards the convex lens, we know that the image is moving away from the lens. That means if I place the object behind 2f, the image will be formed between f and 2f. If the object is placed at 2f, image will be formed at 2f. If the object is moving, or if the object moves between F and F, then the image will be moving behind to F of other side of the lens. By this we can get one information that the image is moving away from the lens as the object is approaching the lens. And when we draw the graph between object distance and image distance, we'll get this type of graph. This graph shows that non-uniform variation between object distance and image distance. But here the object is moving with uniform velocity, therefore the image must move with non-uniform velocity. That is, the velocity of the image is different at a different instant of time. So therefore the velocity of the image is non-uniform and it is varying. So therefore the image is moving with non-uniform acceleration. So therefore the option C would be the correct answer. So the moves away from the lens and then which is posing non-uniform acceleration. Okay, let me go for the next question, that is, the refracting angle of a prism is A and the refractive index of material of prism is cot A by 2. The angle of minimum deviation is, here the refractive index of material of the prism, that is n is equals to, we know that n is equals to sin A plus D by 2 whole divided by sin A by 2. This is the expression for refractive index of the prism in terms of angle of the prism and angle of minimum deviation. Here n is refractive index, that refractive index as they are given cot A by 2. We can express cot A by 2 as cos A by 2 divided by sin A by 2. Okay, here we have sin A by A plus D by 2 whole divided by sin A by 2. So here sin A by 2, sin A by 2 get cancelled. We'll get cos A by 2 equals to sin A plus D divided by 2. Cos A by 2 can be written as sin 90 minus theta, that is A by 2, because we know that cos theta equals to sin 90 minus theta. This can be written as sin A plus D divided by 2. Now this can be written like this, that 90 minus A by 2 equals to A plus D divided by 2. So therefore it will become now, so 180 minus A divided by 2 equals to A plus D by 2. This implies that 180 minus A equals to A plus D. So therefore D equals to, here if I bring A to the left side, it will become 180 minus 2A. So therefore option D, that is 180 minus 2A, is the right one. Okay, we shall move to the next question. That is, the following figure shows a beam of light converging at point P. When a concave lens of focal length 16 cm is introduced in the path of the beam at a place shown by the dotted line, such that OP becomes the axis of the lens. Here are the dotted lines. There we are going to place one concave lens of focal length how much? 16 cm. Whenever we place the concave lens like this, the beam converges at a distance x from the lens. So because of the presence of the concave lens, this concave lens will diverge these light rays. So therefore these will form the image at this point. That is, here we will get the point of intersection of this one. So this distance we need to find out. That is nothing but we are going to find out distance of the image formed by the concave lens, that is equals to x. And here this P acts as a virtual object for this lens. So therefore object distance can be taken as 12 cm that is positive 12 centimeter, because the direction of the measurement and the direction of the incident light rays are same. So therefore object distance is 12 centimeter, and here that v equals to x, and here the focal length of the convex lens is concave lens is 16 centimeter. So that should be taken as negative because it is concave lens. As we know that 1 by f is equals to 1 by v minus 1 by u. What we need to find out here? V we need to find out. So therefore 1 by v is equals to 1 by f plus 1 by u. On substituting the values, that means 1 by minus 16 plus 1 by 12. So this is equals to 1 by v equals to, this is 16 times 12, that is 12 minus 16. This is equals to, is 4 by, that is 4 divided by 16 into 12. So this is equals to 4 1 ja, 4 3 ja, so 3 16 ja 48. That is 1 by v is equals to, is equals to 1 by 48. So therefore v equals to 48 centimeter. So option D is the right one. Okay, let me go for the next question. That is, three polaroid sheets P1, P2 and P3 are kept parallel to each other such that the angle between pass axis of P1 and P2 is 45 and that between P2 and P3 is also 45 degree. If unpolarized beam of light of intensity 128 watt per meter square is incident on P1, what is the intensity of light coming out of P3? Here we have three polarides. Let me consider this P1, P2 and P3, and here the angle between P and P2 is 45 degree and the angle between P3 and P2 is also 45 degree. Here the unpolarized beam of light of intensity, this is here unpolarized light. Let me consider this unpolarized beam of light which is passing through the polaroid P1. We know that this is I, the intensity of the light decreases when it passes through the polaroid first. That intensity is, let me write the I1, this is equals to I by 2, as we know that I by 2. But whenever this I by 2 or this amount of intensity of light is passing through the next polaroid, at the time according to the Moore's law, the intensity is equals to I naught times cos square theta. So, but here the intensity is how much here? This is I1 and here we have, let me write, we are going to find out I2 here. I2 equals to how much amount of intensity is passing? I1 intensity. I1 cos square theta will become. So therefore here we will get, that is I2 equals to I1 cos square theta. So therefore this amount of intensity of light is passing through P3. So therefore here we will get I3 is equals to I2 cos square theta. So therefore here I3, that is what we want to find out, I3 only, that is intensity of the light coming out of P3 is I3. I3 is equals to I2 cos square theta. Here I2 is how much? I2 is I1 cos square theta. So that we can write now I cos square, and here one more cos square, we have cos square theta. So therefore I1 is equals to, we know that I1 is I by 2 cos square theta is cos square theta whole square. So on substituting the values we can get now I3, that is I3 equals to I by 2 cos square theta whole square. That is here I3 equals to I, the value of I is 128 divided by 2 cos square theta, how much? 45 degree whole square. We know that cos 45 is 1 by root 2, cos square 45, that is 1 by root 2 into 1 by root 2, 1 by 2. 1 by 2 whole square is 1 by 4. So therefore this will become 128 divided by 8. 128 divided by 8 is 16 watt per meter square. So therefore option C is the correct one. Okay. Let me continue my discussion with the 41 question in the next video. Okay. Thank you. Thanks for watching.